I'm Dr. Craig Hardesty, and this lesson is going to talk about center and radius of a circle, but specifically how the completing the square concept relates to this topic. Now, you've seen the standard form of a circle, the x minus h squared plus y minus k squared equals r squared, that automatically tells you what the center and radius of the circle is. But you don't have to always be given the equation of a circle in that particular format. A lot of times they'll give it to you in a much more generalized way where none of the elements have been factored and it's impossible to tell where the center and radius is as it stands right now. But I'll look at this equation, and one very easy way to tell that this is a circle is the fact that both x and y are squared. There are really no coefficients in front of them other than 1, and there's an addition sign in front of each other. The x squared is positive, the y squared is positive. Now, at some point you'll learn about parabolas and hyperbolas and ellipses that have similar formats than this, but this is a classic circle. Now, how do I transform this equation into that format that shows me the center and radius of a circle? Well, remember that if your goal is to turn it into this format, you're going to have to do some factoring to get this and this. How do you factor, though, without having all the necessary components? We're going to have to complete the square. So here's the kind of strange process we have to go through to do this. The first thing you want to do is to put the x squared and the x term together and leave some space. Then you put the y squared and the y term together and leave some space. And then throw the constant to the other side. Okay? Now, remember how completing the square works. Since both of these x squared and y squared already have a coefficient of 1, I can go straight into completing the square, which involves taking the middle number, the 8 in this case, dividing it by 2, and squaring that result. So if I take 8 divided by 2, I get 4. If I square the result, I get 16. Now I use a different color to keep track of this. I want to add that 16 in as a new number. But remember, you just added something into an equation. Now you can't just do that without doing the same thing to the other side. So I've got to go over here and add that same 16 in. You just completed the square on the x's. Let's do the same thing for the y's. Negative 6 divided by 2 is negative 3. When I square that, I get positive 9. Again, I want to add that in to complete the square. Whatever you do on one side, you do it to the other side. Now, we don't really need this work. I'm going to erase that back off. And if we've done this correctly, both of these should factor into a perfect square. Let's see what we have. This is going to be x plus 4 squared. This is going to be y minus 3 squared. And on the other side, negative 16 and 16 cancel, so all I have left on the other side is 9. Now, does that look familiar? Because that is the format we were shooting for. So now we can immediately look at that and say, okay, I know what the center is now. The center of this is at the opposite of this one, negative 4. The opposite of this one, positive 3. And the radius, square root of 9, or 3. And that's how we can go from this long, drawn-out, expanded version of the circle equation to the more general form that's where it's factored up and we can easily tell what the center and radius is.